Hi kids, today we are going to finish the if you see this, think this portion of our Tuesday assignment. Last week we completed sections D and E. Now with what the College Board has put out, I think most of what we covered, with the exception of E8, is unchanged. So these are all things we definitely need to know going forward for this year's exams. With that being said, some of F and G will no longer be tested, and I'll kind of go through that as we go along. All right, let's get started. F1, find the area under the curve of f of x on the interval from a to b. So this is a definite integration problem, and you need to integrate the function. In terms of notation, please make sure that you write the dx. I saw that a lot of you were forgetting that. And it's important, so please make sure you're writing it. Find the area between f and g of x. This is no longer tested. Find the line x equals c that divides the area under f of x on a of b into two equal areas. This is MDT, but I'm going to have to double check to see if this is still tested. I'll double check again. I apologize for not knowing off the top of my head, but it's hard to kind of keep straight. F4 will no longer be tested. F5 will no longer be tested. That is your pineapple and Play-Doh problems, along with F6 no longer being tested. But when we get to F7, we see something that's familiar, and this is the start of Chapter 7, and one of the videos actually that I'm asking you to watch this week. Solve the differential equation dy dx equals f of x times g of y. This is where we separate the variables. We use some sort of algebraic manipulation, and we put all the y's on one side and all the x's on the other side, and then we integrate and not forgetting our plus c, and that plus c sometimes is that condition we're going to have to solve for, so keep that in mind for solving differentials. Finding the average value is no longer on this exam. Finding the average rate of change, I think that's going to be pretty standard. There are two ways to do it. One of them is through average value, and then the other would be just to find the average rate of change, like you know how. F prime of x, I'm sorry, does that say t? Yeah, sorry. Erase that. T sub 2 minus f prime of t sub 1 all over t sub 2 minus t sub 1. And all of these problems are going to be AROC problems. Okay, so in the tiniest box ever, we have y increases proportionally to y. This is where we write the derivative as dy dt equals ky, and we integrate, and that integration takes us to y equals c e to the kt. So that will definitely be on there this year. As far as drawing a slope field, use the given points. They're going to give you points, and you're going to plug them right into this slope. And then you're going to draw very tiny tangent lines. Okay, F12, 13, and 14 are BC material, so you won't be seeing those, along with 15, 16, 17, and 18. So that's good. That brings us to particle motion. So the rule with particle motion moving forward is it won't be anything that involves integration. It will strictly be what we recognize as derivatives. So I'm going to try to stick to that as we go through these. G1 says, given the position of s of t of a particle moving along a straight line, find the velocity and the acceleration. Well, if we're given position, we're going to take the derivative, and that will give us v of t. So these things are equivalent in the column. If we take the derivative of that, that will give us a of t, which would be v prime of t, or s double prime of t. There's the relationship when we start with position. Given the velocity of a function, v of t and s of 0, find S of t. You would normally integrate velocity, so find S of t, which I don't think is going to be tested now. And then that S of 0 would be your initial condition. Plug in and find it. Maybe same thing for G of 2. Don't believe they will be tested anymore. Given the velocity, G4, given the velocity v of t, determine if a particle is speeding up or slowing down at t equals k. So what we want to do here is we want to find v of k and a of k. And then we are looking for one of two things. The sign of these two functions, if they are the same, it's speeding up. If they are opposite, it's slowing down. G5, given the position S of t, find the average velocity. Again, this is a rock, so this very well could be tested. And so we're doing S of t sub 2 minus S of t sub 1 over t sub 2 minus t sub 1. G6, given the position function S of t, find the instantaneous velocity at k. This is just going to be S prime of k. Given the velocity function v of t on t1 to t2, find the minimum acceleration. So you want to find a of t and then find a prime of t and set that equal to 0. We're going to use our sign chart to discover whether it's a minimum or a maximum, and then you'll be able to know the minimum acceleration of the particle. G8 is no longer tested. Given the velocity, find the average velocity. We would have used that average value theorem. I also think G9, which is displacement, will no longer be tested. And G10, given the velocity, determine the distance traveled. Again, I think that will be out as part of, they are part of Unit 8. G11, calculating those without, again, no longer tested. I've been saying that for every one of these. Yep. G12, G13's on there. The volume of a solid is changing at a rate of. This is where we're going to do a good old-fashioned derivative. So that's fun. Interpreting the meaning of A to B. This is definitely going to be tested. I think we're going to see a lot of questions about interpreting meaning. This is where we're looking to notice the difference between R of B and R of A. What we won't see is the accumulation one. So where we see R of A plus the integral from A to B of R prime of T dt, I think those ones we won't be seeing. And then G15's out too. Okay, so that sums up our if you see this, think this portion of our review. Please make sure you copy all of those down, and when we're back together, they'll be graded as part of your binder. Have a great day.